In the second video for section 3, we're going to talk about the signs of the trig functions. The way we determine the signs, whether the trig function is positive or negative, depends on when we graph the angle, which quadrant the terminal side of the angle lies. All right. So we remember from a couple of videos ago we plotted the Cartesian plane and we talked about the four quadrants. And just a quick review, we know in the first quadrant x and y are both positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both are negative. And in the fourth quadrant, the x is now positive and y is negative. Another thing to remember is that r, the radius, is always positive. It does not change sign, so that makes it a little bit easier. So if I'm in quadrant 2 and I want to know the signs of the 6 trig functions, we know the cosine of theta is x over r, and x is negative, so the cosine of theta in quadrant 2 will be a negative value. The sign, though, in quadrant 2, y over r, because y is positive, in quadrant 2, the sign of theta is positive. All right, so that's important to remember. Let's go ahead and give an example of this. If I tell you that the sign of theta is negative 5/13, can you tell me which quadrant it lies in? And the answer is you can't give a definitive answer, but you can narrow it down to 2. Because y is negative when it's below the x-axis, and the sign of theta is y over r, then we know in quadrant 3 and quadrant 4 the sign will always be negative, less than 0. Okay, so let's do a problem with some actual values and you'll see how this works out. What about if I tell you that the sign of theta is negative 5/13 and the terminal side of theta lies in quadrant 3? So I have to tell you the quadrant, otherwise you don't know if it's 3 or 4. All right, and so your job is to find the other 5 trig values. Okay, and we haven't actually drawn an angle that looks like this before. Like I say, when we were in geometry, all of our angles fit nicely into a triangle. All right, so in quadrant 3, here I'm gonna go ahead and put the circle in for reference. I'm going to say that if y is negative 5 and r is 13, then x has to be negative 12. Now, I think you remember the 5, 12, 13 right triangle, the Pythagorean triple. Why x is negative 12 is because in quadrant 3, x and y are both negative. So I'm going to try to draw two approximately negative 12 comma negative 5. And so here's my angle. Here's the angle in standard position. And so right away this looks really weird because it always reminds me of an angle that broke its back and it's going the other way. But truly we are talking about this angle theta. Now we can't draw a right triangle that takes into consideration the entire angle. So what we do is we draw from that terminal point vertically, and we connect the x-axis, and we always go back to the x-axis. It's always the x-axis. And so when I draw from negative 12 comma negative 5 to the x-axis, there's my right triangle. So here negative 12 is the x value, negative 5 is the y value, and r is 13. All right, so it doesn't look like any kind of angle that we're used to seeing, but we'll get really used to seeing these angles all the time. All right, so we can now say that the cosine of this angle theta would be negative 12 over 13. We already know that the sine of theta is negative 5 over 13. The tangent of theta is going to be 5 over 12. Because they're both negative, the tangent becomes positive. The secant turns out to be the reciprocal of the cosine, so negative 13 over 12. The cosecant of theta turns out to be negative 13 over 5. And last, the cotangent of theta is 12 over 5. All right, so we can have angles that the terminal side lands in any one of the 4 quadrants. All right, and then the last thing I want to do is, as you've been watching these videos, you might be thinking in the back of your mind, what happened to SOHCAHTOA? And so SOHCAHTOA was how we learned trig back in geometry, and we don't use SOHCAHTOA so much in this class, and this next example will give you a really good reason why we've let go of that and replaced the trig definitions with the ones that hopefully you're really comfortable with now, that the cosine of theta is x over r, the sine of theta is y over r, and the tangent of theta is y over x. All right, when you use SOHCAHTOA, the H in there stands for hypotenuse, and that assumes that we can draw a triangle, and the triangle will have a hypotenuse. And so the next question, where I want you to find 3 trig functions, let's just say find the cosine, sine, and tangent of a 90-degree angle. We couldn't use SOHCAHTOA, and you'll see why that is. So when we draw a 90-degree angle in standard position, we notice that our terminal point here, we'll call that x, y, that we always, from xy, draw vertical back to the x-axis, make the perpendicular. And if you look at that, it isn't a triangle, right? In fact, if you were to find for this point x, y here, the x, y, and r values, you'd find that the x is 0, the y and the r are the same, right? So it isn't a triangle, so we have to think of it in a different way. So we're going to use these new definitions that will serve us very well in trig from our advanced algebra perspective, and be able to find the sine, cosine, and tangent of a 90-degree angle, whereas last year we weren't able to do it. All right, so using these definitions, the cosine of theta is x over r, and if x is 0, the cosine of theta is x over r. Wow, my pen is acting up, which is 0 over r, so the cosine of theta is 0. Let me change colors, maybe that'll make a difference. The sine, oh, it's not letting me change colors. The sine of theta is now y over r, and if y and r are the same, then the sine of theta is 1. Put that number back there. All right, and so then the last one we need to look at is, what is the tangent of theta? Well, the tangent of theta is the r value over the x value, and x is 0, and we know that when we divide by 0, we get undefined. And so the tangent at 90 is undefined. There is no tangent of 90. And if we go back to think about what I was talking about before, that the tangent turns out to be the slope of the radius, if the radius of this rotation angle is a vertical line, we know that the tangent of a vertical line is no solution, and it makes perfect sense. Okay, going to practice this in class and move on. Thanks for watching. See you in class.